So here is our question. We are trying to ascertain the error in the computation of refractive index given the angle of incidence and the angle of refraction. So we have the two angles right here, and we want to find out the error in the computation of this refractive index in terms of the error in the measurement of I and R. So to begin with, let us first we observe that this is just a division of two functions. So it is sin I by sin R. So we can use our division formula directly. So what we can write is the relative error delta n by n will actually be equal to the relative error in sin I, which is divided by sin I, plus the relative error in this entire function, okay, sin R divided by this sin R, okay, because this is relative error. So this is the relative error in sin I, and that is the relative error in sin R. We have to divide it by their respective. So this is the absolute error delta sin R, and this is the once we divide it by sin R itself, then we get the relative error. So that is the first step that we know. Now we have to express this delta sin I in terms of delta I. So for that we use our formula that delta Q is nothing but dq by dx of, and multiply it with delta x, the change in the error in x. So that's what we will use here. Delta sin I is nothing but, okay, I'll write it right here. So delta sin I is nothing but differentiation of sin I with respect to I multiplied by del I. So differentiation of sin I is actually, we are only interested in again the magnitudes. So the magnitude is just cos I, and multiply it with delta x, which is the x in our case is I. So that is just delta I, and we divided it by sin I, plus the same thing we'll do here. This is just again cos R, multiplied it with delta R, divided it by sin R. Very, very simple, nothing difficult so far. And this cos I by sin I is nothing but cot I delta I plus cot R delta R. So here we have represented the error, the relative error in n. So this is nothing but del L by n. The relative error in n with respect to the errors in the measurement I and the measurement of I and R. Of course, when we are using this formula, we have to make sure that we are doing I only in radians. Again and again I am saying that as soon as we use differentiation and integration, we just make a habit of converting all our angles to radians. Never use angle in degrees, otherwise your answers would come out to be wrong. So provided that you have done that, this is a simple numerical example. Many more numerical problems you can find on DoorstepTutor.com. So definitely do practice this problem as well as the other problems. Thank you.